Electricity is cool, isn't it?
Electricity surrounds us. Electricity controls almost everything in the universe, from the neural signals in our body, to this amazing iPhone X, to this wristwatch I'm wearing, to even that electric water heater. And the fact that we take all these electronic appliances for granted just stuns me. I mean, we should at least try to learn about them, about how they work, and about how they were invented. So, dear Science Whizz fan, without wasting our time,
Let's enter the world of electronics. Tutorial 1. By the Science Whizz. Now, this is a beginner's tutorial. For something more complex, check out our other videos in the technology playlist.
but if you are a beginner and you're excited about learning about electronics, then this video is for you. So, let's get started.
For this project, we'll need one LED of any color, a 470 ohm resistor, couple of wires, doesn't matter which kind of wires they can be alligator clip wires, they can be anything. And finally, 4 1.5 volts AA batteries in a 6 volt battery compartment.
We'll be building this project on this special baseboard that I have, and using these special springs. Now these things come in a kit, so you won't be able to buy them. However, you don't have to use these springs and a baseboard to build a circuit. You can just connect the wires together and make it without the help of a baseboard or springs. Now, don't worry if you don't know what an LED is or if you don't know what a resistor is, because after all, I'll explain it to you in the end. So, step 1 is to put one of these special springs into one of the holes on the baseboard. Just like this. Leave a gap of at least 2 holes between the special springs. Step number 2. Connect 2 of those springs with an LED. Like this. Step number 3. Connect those 2 springs with the resistor. Like this. The 4th step is to connect those 2 springs with a wire. Like this. Easy peasy lemon squeezy. Step number 5. It's time to add the battery. Now with the battery we need to be specific. Connect the red wire, yes, the red wire there, and connect the black wire there. Why? Well, because the red wire symbolizes the positive terminal of the battery and the black wire symbolizes the negative end of the battery. You need to put the positive end of the battery with the positive end of the LED, and similarly you need to put the negative end of the battery with the negative end of the LED. If you don't, if you mess up, then the LED might malfunction. Now, how do you tell the difference between the positive and the negative ends of an LED? Well, the positive end of an LED, called an anode, is generally longer than the negative end of an LED, called a cathode. So, let's put the red end of our battery, which is the positive terminal, there. And let's put the black wire, come on, there. And there you go, your circuit's working. Whoa, why is that LED flashing? Well, that's because that's how it is. It's a flashing LED, not a normal LED. But normal LEDs work in the same way as flashing LEDs. They have a cathode and an anode.
Now that we've made the circuit, let's learn how it works.
Now let's discuss all the components in this circuit. Now guys, I'm sure you know what batteries are and what wires are, so I'm not going to insult your intelligence by giving you definitions of batteries and wires. So let's move on to the LED. LED stands for light emitting diode. LEDs have two LEDs, anode and cathode, and a plastic translucent, usually red, green or yellow, cover that houses a small semiconductor element. When the current is passed through the device, the LED glows brightly. The LED is similar to a bulb, but not completely the same, because bulbs don't have negative and positive ends. They're not polarized like an LED. Next, let's discuss the resistor, and specifically the 470 ohm resistor. Resistors are used to limit the amount of current flowing in a circuit. The higher the resistance, the less current that flows, and vice versa. Resistor values are measured in ohms and are identified by the color bands on their bodies. They may be connected into the circuit either way, so they're not polarized like an LED. So how exactly does the current flow in the circuit? Well, first, let's insert the batteries. Now, the current flows from the positive end, that is the red wire, through there, through there, through there, through the anode of the LED, into the LED, out through the cathode, through that wire, and back into the battery via the negative end of the battery. This completes the circuit. The resistor limits the current flow through the LED to a safe value. Without this resistor, the LED would quickly burn out and be destroyed. So, don't do this project without the resistor. It could explode.
If this is your first project and you've got it going, then congratulations! As I said in the beginning of the video, if this is your first time into the world of electronics and you've just begun your journey into it, then I assure you, you're gonna have an exciting time ahead. And that brings us to the end of yet another amazing Science Whizz video. Wait a second, is that really the end of the video? No, it's not, because we have some bloopers for you. If this is your first project and you've got it going, then yeah, can you please stop doing that?
Step number 5. It's time to add the battery. My brother laughed, sorry.
Step number 4.
Oh damn, the thing fell.
Stop! But wait guys, before you stop the video, don't forget to check out our website, which is the Science Whizz, not the Science Shiz, the sciencewhiz.wixsite.com/thesciencewhiz. I know it's a very long URL, but guys, I just couldn't change it. Very sorry about that. And thanks for watching. Stay tuned for more videos.